Scientists from Singapore and Japan have co-developed a bird flu test kit to detect the virus in hours, compared to 3 days with conventional methods. The breakthrough with a diagnostic kit, Steadfast, could be a game changer in the fight against the global spread of bird flu. Now, for more on this, we have Dr. Masafumi Inoue from the Diagnostics Development Hub, or DXD Hub, a national platform under A STAR, and Dr. Sebastian Maurer-Stroh from the A STAR Bioinformatics Institute. Thank you so much for joining us today, gentlemen. Dr. Masa, first of all, tell us, in what way would this kit be a game changer in fighting avian flu?
Okay, this kit enables to produce the information whether H5 avian influenza is highly pathogenic, which is severe or mild, in 2 hours, which takes usually 3 days to confirm. So this is why we call it a game changer.
And so detecting the virus in 2 to 3 hours, as you said, compared to 2 to 3 days with conventional methods. Why is swift detection for the viral strains, particularly for the H5N1, so crucial?
H5N1 is crucial is because it kills all the birds when the virus contains a highly pathogenic segment in the genome. So that is why this kit is important to identify which is HP or low pathogenic.
And how will this influence biosecurity at poultry facilities?
I think this one.
Yeah, I can.
Dr. Sebastian, maybe you can jump in here.
Yeah. It's important to know if wild birds near those facilities are infected, because this is how the virus spreads. There are H5N1 cases around the globe. The virus has been moving from Asia to Europe to Africa to the Americas, even down to Antarctica, where penguins, luckily, were only mildly affected. So it's important for poultry farms to be aware where the virus is moving so they can take preventive measures.
And can this kit detect all the existing strains of the avian flu and possible mutations?
In surveillance, the first step is to detect that there is an avian influenza. So this kit is designed with a smart combination of probes to detect all of the influenza A viruses that could be harbored in the birds. But importantly, it has additional detail, like this mutation of this additional highly pathogenic feature for the birds. And this combination allows us to detect all the strains with more detail on the most common strain that we're all currently monitoring.
And I see that you brought along with you the test kit. Maybe you can show us how it works.
Okay. This kit is used. First, we isolate the virus genome from the disease sample. Then we mix the genome with all this reagent and mix into the one tube. And bring this mixture to the PCR machine. And after 2 hours, it performs within 2 hours, and the result will come out.
I imagine a big team is behind this.
Yes, our team, can perform.
It is very fascinating. Is this kit commercially available right now?
Not yet.
Not yet.
But we are planning to.
And what are those plans?
What are those plans? We are looking for any commercial company to manufacture all our kit to the users.
All right, and Dr. Sebastian, so this is described as a game changer. How big a contribution is this for the global scientific community in pandemic preparedness?
Yeah. To add, this also has been tested and field tested in Japan with our collaborators. So before the commercial application, it goes through rigorous testing. For the global impact, this is exactly where it leads to. When the virus has circulated around the globe, it is important to always know which variant is present. And there is, as a first step, quick diagnostics. The second step then is genome sequencing. And these genomes then are shared globally. And this is for the global impact, where we look at our preparedness vaccines working. the Global Data Science Initiative, GISAID, is where those genomes get deposited and then are being shared around the world. And we are partners of the initiative.
Sure. Are there any plans to create something similar like this for other viruses?
There have been diagnostic kits for several of the previous viruses during the pandemic, also for monkeypox. There are our colleagues in A STAR and are preparing for more infectious diseases and studying the mechanism of these diseases.
And this kit is, of course, the result of a collaboration of 3 institutions. Share with us briefly about this collaboration. How did the idea first come about?
Okay, the Japanese collaborator, NIES, National Institute of Environmental Science team, was looking for the more rapid test to find out whether this virus is a dangerous form or mild form for their work, which usually, as I said, it usually takes 3 days. So we know this Japanese collaborator through our acquaintance. Then we discussed, and our team designed, and with the BII team provide genetic information. Then the product is tested by NIES team and confirmed that it matches what they expected. Yeah.
Dr. Sebastian, what about you? What are your hopes next for this kit?
I think it's a good way of trying to be cost effective when you're looking at always chasing the latest evolution of the virus, because it's the first step, and then you can stagger it with additional follow-up methods. So we all hope that those kits are never needed and never used. So the ideal case is we don't need them, but it's very important to be prepared. So this is why we are always one step ahead of the virus.
All right, it's always good to be prepared. Dr. Sebastian, Dr. Masa, thank you so much for joining us in the studio tonight. That was Dr. Masafumi Inoue from DXD Hub and Dr. Sebastian Maurer-Stroh from the Bioinformatics Institute.